Morning everyone. How are you doing? Feeling pretty good? Day 2. Yes, as I said, my name's Nash. I'm a developer evangelist for Twilio. It's my first time here in Warsaw, so I'm having a really nice time so far. It's been a great conference so far, so I'm really enjoying this. Anybody heard of Twilio before? Just a quick show of hands at all. This guy knows. Yeah, a couple. Okay, let me just tell you a quick bit about us. We are a cloud communications platform. That means that we give you the ability to make and receive phone calls or send and receive text messages in your applications using the tools, languages, or frameworks that you already know. So actually, there's a test there already. That's a good start. I want to give that a quick test. This is my kind of warm-up, my check that everything's actually working, as you can see on my slides there. Check that everything's working, how to ruin something. If you send a text message to that number right now, then you should kind of get a response, see what happens. We'll start seeing the text up on screen. Would have been a surprise if there wasn't a test written up there, but if you send a text here to 799449268. Hello, Warsaw. Cool. So texts are coming through. You should get a response back. And that's kind of a little bit of what we do. Like I said, it's kind of my little warm-up, just to make sure all my things are working on my presentation right now. Is anybody else getting any texts? Lol, exactly. Cool, so it works. That's a great start, and my tech check is good. Thank you very much for helping. So, today, I'm going to cover a few things. I just want to talk a little bit about communication, and then a bit more kind of an introduction to WebRTC, and tell you what that's about. A bit about implementing WebRTC, and I'm not going to kind of go deep into the code necessarily on that, because this does work cross-platform, and so I don't want 3 sets of different codes up there and things like that. So it's going to be a higher level look, but about the things you need to know about when you're implementing any kind of WebRTC thing, and then kind of some applications of WebRTC. So first, thinking about communication. Kind of like, mobile apps are all about communication. I don't necessarily mean just phoning people or texting people. That's not even an application. That's default kind of stuff. But we're talking about communicating with our phones, with our devices, with our external things that we use. And what I also like about mobile is that it's very much about context as well. Without a context, you could be anywhere doing anything, but the mobile apps can know an awful lot about you, and what you're doing, where you are, what your intention is, and that's really useful. I'm sure you've used that in your own applications before. So if we just consider this mobile phone user, and what the most important thing in this picture is. I'll give you a hint, it's not the bench. Admittedly, she would be sitting on the floor if there was no bench, but the most important thing is not the bench, nor is it the phone, in my opinion. It is, of course, the user. It is the person sitting there using it and talking, communicating, trying to get something out of their phone. I don't know what she's doing, but I imagine that the phone and the application does. So I really like the tagline for this conference, Mobile with a Human Touch. We can produce context and communication via some lovely things, and I don't know if you were in the last session, but there's some beautiful kind of design elements that just add to the experience of using an application, and that kind of makes something human. But I want to take that a little bit, one more step further. So has anybody kind of seen this before? This is Amazon Mayday, so built into every Kindle Fire device. There's a little button where you can press and get somebody like Amy to answer your questions. Not always Amy, although some people do request her. She's probably just an actress. But basically, and the good thing about this is that you can see her, she can't see you, so you can be doing anything on your device at the time. Although she can, I think, see the screen, and so she knows the context of what you're up to, what you need help with, and what's going wrong for you. And Amazon introduced this on the Kindle devices in 2013, September 2013, and in a report April 2014, 75% of all help requests from Kindle users, Kindle Fire users, came through the Mayday button. And the average response time was in under 10 seconds, 9.75 seconds or something. So people were having problems and getting them sorted very quickly, just straight by talking to somebody. I want to give another quick example. I think Uber is fairly new here in Poland, but it's kind of, I'm sure if you've not heard of it, it's a taxi hailing application, which, much like other apps these days, like knows a lot about you. So rather than having to tell a taxi firm where you are, it already knows that. You've got GPS telling them exactly that. But what's great is once you've booked a cab, on the menu, you can actually, at the top there, is contact driver. So once you've booked something and set your place where you're going to meet him, you can bring up this menu, hit that, and within the application, dial the driver and tell him anything that you need to, any more information, find out where he is. If he's going to be late, he can call you, same using his application. And basically, it just makes it that much more useful, that much better. Rather than, again, in the old days, if you'd call up a taxi firm after you'd booked a taxi in the first place, you have to remind them exactly who you are and where you're going and where you were and things like that. This is all just sorted by context and then communication. And both of those systems are, of course, powered by WhatRTC. So we probably better go into what WhatRTC is. This web real-time communications, pretty simple. I've been pretty excited about it for about 3 years now. When I first discovered browser starting to do this, and this is a forked version of Opera that had the very first get user media APIs built into it, which allowed you to get the camera and microphone from your computer, and I was pretty happy about that, and it's and so WhatRTC also is really real time. There's been a lot of real time applications around the internet and when building apps, but a lot of them kind of use an intermediary server, which, I mean, it's still quick, things like WebSockets or any kind of other polling that you can do, but it's not really real time. And WhatRTC is finally peer-to-peer connections, so you do not have to go via any of the servers. You are going straight to the other application, straight to a browser, straight to something else on the other side. That makes it much faster and properly real time. And now you're probably thinking, hold up, he keeps saying browsers and web and WhatRTC. It's a mobile event, right? So let's talk about support and who actually does support this. And sure, I'm going to talk about browsers first. And that, Chrome and Firefox and Opera do support this, and Safari and Internet Explorer hold everything back. But more excitingly is that this stuff works across mobiles as well. And there are supplied by the WhatRTC Foundation, which is kind of run by Google, pushing this. There are SDKs for Android and iOS that allow you to use exactly the same protocols that are being put together, not the same protocols, the same SDK, the same APIs that are being put together by the W3C for the web on devices as well. Those are the only two operating systems, right? I saw somebody with a Windows phone yesterday. I don't know what he was doing here. So the APIs for this. The APIs for this are kind of media streams, which allow you to take those kind of input of cameras and microphones and other inputs that you want to stream to anywhere, and wrap that up in a kind of set of tracks, of video and audio tracks and other such things. There's the RTC peer connection. This is the basis of all connections that you ever want to make using WhatRTC. On the web, it went through a number of naming things. It started off being called the peer connection, which kind of makes sense, except they made it wrong. It got called peer connection 00 at one point, but I'm glad they got over that. We're now on RTC peer connection, and we're pretty solid with that, I think. And then if you don't want to be sending media, if you don't need to be doing audio or video, you can do, with the RTC data channel, which this one is still moving about a bit in the standardization process, but just arbitrary data, text or binary, streamed peer-to-peer as well. So those are the APIs that we use. And what does it do? Oh, I've got a little demo. Now this demo broke this morning, but it should just work for me right here. So this is how it works in the browser. Quite simply, I can grab my own video stream, and then, oddly enough, because of networks and things like that, I can grab a second one. And then back in here, I can initiate, like, this is where I initiate my peer connection and call myself, and eventually I appear in double. Wonderful. I didn't want to trust the network in this room to get somebody else's video on there, so that worked. I did have a fail slide just in case it didn't work, but we can move on, right? That's awesome. The first time I gave a version of this talk, it did fail miserably, and I led with this slide, and everybody laughed more. So how does it work? How do we put this all together? How do we get to this place? So I have two friends who want to talk to each other, Alice and Bob, in our classic naming of anybody in computer science whatsoever. Alice wants to talk to Bob, Bob wants to talk to Alice. So the first thing they need to know is, are they there? And so I might have talked about peer-to-peer in this kind of, there is no intermediary server and nothing to do for the back end when we're translating messages between people, translating audio or video between people. But to get this all kicked off, you need a server. And so this is a server that it's pretty much the same as server that anybody who's ever built kind of a chat room or a chat kind of experience via any other kind of sockets or other method like that. It just needs to be able to say, all right, Alice is logged on. No, Alice, there's nobody else here. And then Bob logs on, and it goes, Bob, Alice is here. And it also will tell Alice that Bob has just turned up as well. So fantastic. They know each other are there. Alice knows Bob's there. So, but she doesn't know how to talk to him. She just knows he's there. He's just also at a computer or a phone looking at the same application. So now we get onto the sexy kind of acronym stage of things where I get to talk about abbreviations for a while. And NAT traversal. I'm going to leave it up to Vanilla Ice. I don't know why. So I love this picture because it shows Vanilla Ice's complete belief in open source, as he has tattooed on his knuckles wide open. But it's really, we'll get to the joke in a minute, I'm sure. It's about ICE. ICE is the Interactive Connectivity Establishment Protocol. This is what is built into WebRTC and is how we actually find out how to talk to that other browsers. And so the problem is network address translation. That is what gets in our way, NATs. It's basically because we're out of IP addresses. And so every time, whenever you're on a kind of local network, that is going to be masked to the public, to the rest of the world, by kind of a public IP address that everything flows through. And so in order to talk between applications, in order to talk direct app to app or browser to browser or app to browser, we need to find out that IP address and a port number on which we can contact our peer. And so we do that using a stun server. Stun, Session Traversal Utilities for NAT. Very sexy sounding name. I'm sure they make these up just to get good kind of ways of stun. Ooh, stun server sounds cool. What a stun server does is what I do for myself when I Google what's my IP address, and you get the answer back. Like, it is basically a server that is very much set up straight to tell you exactly back where you're coming from. The only problem is, in terms of a symmetric NAT, I don't know why it's called symmetric, because it's really not, because if you find out your IP address, your public IP address, and you're behind a symmetric NAT, the thing that told you that that's what your address was can talk to you over that address. Nothing else. It can't be shared. And so that's where we have turn, which is an extension to a stun server that allows that situation to become, the turn server becomes a relay. So because the turn server knows where you are and is the only one that can know that, you share the turn server's address with the peer to talk through the server. So sadly, if you end up in that situation, you are not quite in a peer-to-peer situation anymore because you have the turn server in the middle, but it is better than nothing. And so this is what happens in our little diagram. Our users are hidden behind their networks. and we introduce a stun and turn server. I have a little Twilio logo on there because we offer them as a service. You can get them from other places. I just happen to have that nice little cloud logo over there. So we have stun and turn servers in the cloud. And Alice gets what they call ICE candidates. So we find a bunch of different kind of routes and different ways that can be spoken to the application and send them. Bob is also going to be doing this at the same time. So this is, you set your RTC peer connection object up, you give it a stun server URL, you give it a turn server URL, and this is what the APIs, the SDKs do the work for you and go start generating candidates for being spoken to via those stun servers. So you need one further thing, signaling. We need now to share what our access kind of IPs and port numbers are, and so we need signaling. And kind of our server that was already doing the presence can do this as well. So once you get a nice candidate, you just send it straight through the server, and the other and your peer will get that. So Alice can send them over to Bob. Bob will send his to Alice, and they'll eventually agree on a way to do it. Finally, if you are using media, if you are using video or audio, you need to share across the applications. You need to share the capabilities effectively. And so when you create an RTC peer connection object, you can add your streams into the object and then generate a description of that. This uses SDP, the Session Description Protocol. That might be changing in the future, but for right now it's SDP. And simply you set up your your codecs, the audio, the video you want to send, and send that again via the signaling server off to the peer, who will then get those and match them up with what they know about themselves, send back the options that work for both people, and at that point, you can make a connection. Hooray! And they're talking to each other, and they're waving at each other in the videos and everything, and it's wonderful. Or they're behind a symmetric NAT, and you get a turn connection, and you go via the relay. But either way, those are the steps you have to go through in order to set up a WebRTC connection. And once you've done that for the first time, you celebrate and close your laptop and leave, because the error messages are terrible. And so getting to that point is fun. But knowing is half the battle. So that's where we're going with WebRTC so far, and how you kind of put it into your applications. I want to talk about a couple of other things, ideas that I've seen on the web that have been used for that use WebRTC to do something a bit different, something that's not just talking to each other, video and audio. So Waggle Dance is a distributed kind of video player. So when one user hits a server, starts playing a video, they start saving chunks of that video locally, and then as other users go to start watching the video, the central server doesn't have to send all the video out to them, but in fact they can get video chunks from peers who are online, saving everybody bandwidth, I'm sure. This is, the code is up on GitHub, and it's a kind of proof of concept. There was a great video of the guy who wrote it talking about this at Reject.js a couple of years ago now, actually. Probably doesn't work with the latest standards, but yeah, maybe he's keeping up to date. Similar idea to Waggle Dance was a project called PeerCDN, which was the same idea, but for media assets, CSS, JavaScript, that kind of thing on a browser. They got bought by Yahoo, so... WebTorrent is another kind of similar idea. So you can build an entire torrent client within a browser and within Node.js. That was built by the team who built PeerCDN, so I don't know what they're necessarily doing at Yahoo, but that's where they are now. And then gaming, live gaming against friends. Oh well, you can have live gaming against friends. This is a great use of real kind of peer-to-peer connections, because it's absolutely it is the fastest you can get. It's what you have. And one of the examples of this was CubeSlam, which you can play against a bear, but is much more fun playing against your friends. This is my colleague Carter, who's out in Seattle, looking kind of confused. But yeah, this is a Pong-style game, but you can chat and see each other and play against each other in real time. And so the opportunities, obviously, for real-time gaming are much nicer, much nicer. Yeah, and actually, I hadn't done this before a couple of nights ago, and I'd only played against the bear, who's great and all, but he doesn't chat much, and you actually get like the full video and audio. You're not just waving at each other, but you're talking, and you can trash talk each other and everything. Absolutely wonderful. And so one final thing that we can do, and this is kind of the same as the example with Uber in the first place, is we can make phone calls from our browsers or applications, and so those text messages you sent in the first place, I can actually call you back, and this will call a random person. So if I'm just going to hit that and see what happens. If your phone rings, feel free to answer. It'll just come out of my speakers here. Is anybody ringing? Somebody's got to be ringing. Marcus is ringing. Fantastic. Go on, answer. Say hi.
Hello. Hello.
You can, if you can hang up, because I didn't build a hang up button into my slides. There, it's gone. It's gone. So that's pretty cool, right? We can make phone calls from browsers. We can chat to our friends during games. We can do all sorts of crazy things with peer-to-peer stuff. And I just want to go back to kind of the Amazon Mayday things. And not only did they have like business kind of wonderful results like 10-second response times to users in need, but in the time between September and April, 44 of their advisors sang happy birthday to a customer. Oddly enough, 648 advisors had somebody singing to them via their Kindle device. 35 advisors received marriage proposals. That must be a level of support beyond anything you can imagine. 3 customers asked for a bedtime story. I assume they were told one. I don't imagine that was in the script for the advisors, though. And beautifully, one customer, because there's the whole access to the screen and everything, asked for help with a particularly difficult level of Angry Birds. And working together, the help advisor and the user eventually pass that level. So that is the sheer power of WebRTC available to us right now. So if we go back to the tagline of the conference and everything, human with a mobile touch. It's a very literal way of looking at it, I suppose. But I really like the fact that we can, within our applications, we can connect people together. We can connect to support. We can connect to our peers, other users of our applications, and this can just add that extra touch, extra way of helping and making things just work for our users. There are some resources. I will put these slides up online with more links than that. That bit.ly link is a blog post I wrote about this in JavaScript, and the GitHub links are this presentation. I'd really like, actually, obviously we've been doing the kind of touching of our little badges against thumbs up and down in the last day or so. But I'd really love it if you could answer this question via text to me, so I can help improve myself. So if you could text just a number on a scale of 0, which is the lowest, to 10, on how likely it is that you would recommend this talk to a friend or colleague, that would be absolutely wonderful. It's the same number we used before, so that would be really helpful for me. So other than that, I think it would be great to talk more, if we have time in questions, or for the rest of the conference, about whether you think this is something that can help, whether you think, whether you just discuss like the ideas of WebRTC and how peer-to-peer communication can improve our applications. I will bring that back up in a minute, but I just want to say thank you very much for sitting and listening to me, and yeah, please do come up with any questions. Thank you.
Hello.
Hey.
Could you please tell more about Twilio and your business, maybe your SDKs you provide, your experience, and so on?
Oh, sure. I can certainly do that. So we have SDKs for iOS and Android in order to make and receive phone calls within your applications. We also have kind of back-end SDKs in 6 languages: Ruby, Python, PHP, Node.js, Java and C#, but like the whole thing is just a REST API, and so all you need to do is make any kind of REST kind of request to the API, which will allow you to send or send messages, make phone calls, and you can set up webhooks for when you receive messages and phone calls. So in the case of the slide at the start, that was a webhook I had for every time somebody sent a message in, my server got the message, and then I WebSocketed it into the browser here. So that's how that all works. I'd be happy to talk more about that afterwards as well. We had another one in the middle. Oh, now we got them there.
You were talking about peer-to-peer connections. Is it possible to make a typical live video streaming application with a dedicated server in the middle, and you stream the video from one device to the server, and it broadcasts it to many?
Oh, absolutely, yes. There are a few open source varieties of those servers around. They can be a bit difficult to set up, but absolutely you can do that. I mean, those are also useful in the case where you have like a multi-party conference kind of call, because each time you set up one of those connections to appear, you are sending another data stream, you are sending another thing out, and you are receiving more in as you get them. So at the point of about 6 people in a conversation, your bandwidth starts to break. And so at that point, it is best to move things to a central server, which ties the video and audio together and broadcast it back out again. So yeah, that sort of stuff is absolutely possible.
So is it possible to integrate it, for example, with the WOZA media server? Do you know the solution? WOZA media server, you know that solution?
I don't know, I'm afraid.
So forget about it. Okay.
we can look that up afterwards, though. But I'm not 100% sure on that, I'm afraid.
I would like to ask about the current state of iOS and Android SDKs for the technology.
So they are,
and maybe about the roadmap for the standardization process.
So the standardization process, if I can answer that first, is going through the way that the W3C goes through standardization. So it takes a long time, and it requires multiple implementations before anybody agrees on it. Thankfully,
what is the state right now?
So we have 2 agreeing implementations between Firefox and Chrome. They are interoperable, and so the APIs are pretty much set. There's probably edge cases that they're dealing with right now. In terms of then the iOS and Android SDKs on that, those are built by the team behind the WebRTC integration in Chrome, and so they are kept up to date with all the latest changes as well. So basically, it all kind of moves. Certainly on the Chrome and iOS and Android side of things, it kind of all moves at the same speed, and in the agreement that the same team is working on it. Firefox then keeps up on the other side. In terms of the future, Internet Explorer decided to make that difficult for us by rejecting the idea of the current API. They wanted to make a more object-oriented one, and so WhatRTC is the potential future for it, which is kind of a WebRTC 1.1, which I think does away with a few of the implementation details that we had to go through today. I mean, you still need to do the signaling and things like that, but I think SDP, the media descriptions might well change and be a bit more. I'm not sure where it's going. I haven't looked too deeply into WhatRTC just yet, but that's where the future of it's going. And I think there's somewhat agreement on that.
Okay, and about that data channel you mentioned?
Oh, the data channel. Oh, yes. It works. It does work, but people describe it as still a touch more in flux than the rest of it. But yeah, I don't know how to describe it much more.
But it's the case of current implementation, or the
there is a current
between the Firefox and other parties?
I believe that the interoperability is as good as the rest. I'm not 100% sure on that though. Yeah, let's take a look afterwards. I will tweet research on that sometime.
Okay, thank you. Oh.
What's the advantage of using Twilio SDK over the public WebRTC SDKs?
Okay, so the Twilio one actually allows you to make phone calls as well. So you can connect client to client via our thing, or call out, as I did kind of at the end, to an actual phone. So that was the phone ringing via the actual phone network, as opposed to just sticking within peer-to-peer across the network kind of thing. So it reached out into the new network. It allows that kind of extra power in that respect.
As for implementation, how would you assess the complexity of delivering such solution like this Kindle Mayday? If assuming I have a mobile app and I have a support team, but they can also only contact through a phone call,
right?
Would it like just to add this kind of feature so that they can call in directly, see the screen, etc.?
So, what's the simplicity, complexity of it? Sorry.
Yeah, like time, cost of such.
I dislike estimating time on my own projects when I know how I'm building it. I would hate to try and estimate the time of your team and your thing. I don't think I can answer that, I'm afraid. I mean, just once you kind of go through the process of doing the signaling, the presence, and sorting out your NAT traversal, it's very much that you get your connections, and then it's very much a case of tweaking to your own thing. But there's absolutely no way I can estimate the amount of time to do it, I'm afraid. Sorry. Sorry? I would say it was somewhere in between that. It's not going to be days. There is complexity to sending video streams around the place, and there is. But on the other hand, I don't think it should be months. Depending again, size of team, understanding. I don't think it should be months. Somewhere in the middle, weeks maybe. One at the back. Is there? Any other questions there?
Okay, one more question. Okay, so as customer, for example, if we decide to use your SDK, what are the price, what are the payment and monetization strategy for your application?
Oh, okay. So Twilio is kind of pay as you use. There's no contracts. There's no things like that. It's very much like on minutes dialed and messages sent, things like that. So it's all very reasonable. We can talk about pricing offline. I don't think anybody else necessarily wants to know about that right now. But I can show you the page. It gets complicated after a while, but it is as you use it. So if you only use a tiny amount, you only pay a tiny amount. If you suddenly become a large customer, we'll talk to you.
So when establishing a RTC connection, is it using the data plan of my provider, or is it just like a regular phone call to?
WebRTC is all going to go over data.
Mm-hmm.
Yes, I don't think we can be sending video over our phone lines, sadly. Which
so how many kilobytes by minute is it using? Because often it's you have this amount of 300 megs for 1 month, and if you
sure. So an application itself can kind of define that by kind of downsampling the video. So you probably don't want to be sending your full capability of your iPhone kind of camera out along the stream, because it's gonna be laggy, it's gonna be terrible anyway. But it is also going to ruin people's data plans if they have them. So as an application developer, I would recommend downsampling to a size that you think is worthwhile for the user still, but as efficient on the use of data. Whether other people do that with their applications, I don't know. I would assume Amazon have done a good job. And of course, you can work out, am I on Wi-Fi? Am I on a 3G connection? Am I on 2G? And so probably not worth even trying.
Question about WebRTC itself.
Yes.
Does it define a wire level protocol for data transfer, or it's just an API?
Say what, sorry? Does it
define a wire level protocol, or it is just an API and then the protocol is up to the library who implements the API?
Yes, that's up to the implementer. I think the idea of it is to take the hard decisions, such as the actual on the line protocol, and hide them away a bit from the developer, just to make it easy enough to set these things up without having to do all that work. I'm sure within a mobile application kind of context, you could come up with your own. But this one obviously has taken years to get to this point. So I always like allowing those professionals to have covered that bit, and then I go and make the application on top of it. But yeah, I'm sure you could make your own if you want, but I don't think you get necessary access to it either. Yeah, you have the API level, and that's kind of it.
Is it possible to open more than one connection between peers?
Yeah, absolutely. As I was saying earlier, like you can keep opening connections and keep bringing more connections in and sending them out. There is a point in which, for example, if you're sending video and audio data to those connections, it's just going to be it's going to fill the bandwidth, and you will, you got nowhere left to go, and that's going to ruin the connection. And at that point, you want to tie it together into a media server in the middle. But yes, you can open as many as you can open without crashing your application.
And if the peers are on the same network, a local network, are they using their local IPs or no?
I'm not 100% sure on that, but I think that is part of the kind of ICE candidate generation process. Will be like, you could talk to me on this local thing, and if they both agree that that local thing is there, then yeah, I think they can in fact talk over it. That is a guess. It is also the case that if you build up a WebRTC, if you build up an RTC peer connection object and don't give it any stun service to go and check the outside, the only candidate it will come up with is something on the local network. So that's why I think that will work.
Okay.
One more question. I'm not sure if I get properly it. So, for example, we have two Android clients. They would like to make a talk. Yes, they are like peer-to-peer connection, but we use your middleware to establish this connection. How is it? How is making them to connect? Like a board we have or something like that?
So, in the case of the actual Twilio SDK on that, currently. It all does go through the phone line, so you cannot do a video connection with our SDK right now. It does make it will hit the phone lines at some point, so it's also not a great connection audio. So in that case, that's where the full kind of WebRTC implementation would kind of lie with your side of things, although there are other libraries out there to make that slightly easier. Yeah.
So I would like to be clear. So if we need some secure, for example, secure messaging between two clients, can we completely migrate it to our server? So not affect in any type as any external
yeah, absolutely.
servers.
Yeah. You can entirely use your own service for all of this. Yes, and security is very much in the hands of the implementer and should be considered. Yeah.
How does this compare on the scale to SignalR in terms of where this sits kind of on that sort of platform? I don't know if you've heard about it.
I have not heard of SignalR.
So SignalR is Microsoft's basically peer-to-peer solution over HTTP.
Okay.
That's a pretty powerful technology, and it's also open source. I'm just curious if...
I'll be honest, I haven't heard of it before, so I can't make a comparison right now.
Really interesting.
That is cool, yeah.
It's very, very similar, and I'd like to see kind of how it stocks up.
Since Microsoft are kind of driving this move to ORTC as WebRTC 1.1, I imagine that they are bringing opinions from that, and yeah. So like ORTC is will continue to be standardized as well as open source. I don't know necessarily if SignalR is part of a standard or just Microsoft's ideas, which are open source, which is cool, but not necessarily a standard.
Yeah.
I hope if it is a good protocol, then indeed it does bring more to the table for ORTC. That'd be brilliant. And there's one at the back there.
How about security?
Security is very much up to the implementer. So it's if you're signaling channel, you need to keep that secure. You need to do your own authentication. WebRTC doesn't give you any of that. The only thing it's going to give is that kind of straight peer-to-peer connection. is as secure as that can be. I believe it runs encrypted, so it can't be interrupted. The only thing you might want to consider is if things go through a turn relay, whether that's a good or bad thing. I should have mentioned, recent research suggests that around 14% of WebRTC connections might need to use this turn server to get in the middle. So that's something you might want to consider, particularly if you want to use a third-party stun or turn system. It's possible to set the servers up yourself, of course. There are open source varieties also linked to from the WebRTC kind of project.
Thanks.
Right, wow, I think that's
far the longest Q&A section I have heard here.
Thank you very much for all the questions and for sitting and listening.
Thank you, Phil.